Hello everyone. Due to popular demand or not, sa video ito gusto kong i-detalye ko na talagang ginagawa ko sa research ko. Last week actually, kakatapos ko pa lang ng isang malaking presentation. Ang tawag namin is Works in Progress or WIPs. So I thought, why not make a video about my project since it's still fresh in my mind. So basically, sa video ito gusto kong i-detalye kung ano talagang ginagawa ko sa lab, anong research topic ko, and of course what my day-to-day looks like. So, what is my research about? Ang research ko specifically ay nakafocus sa isang type of kidney cancer na ang tawag ay clear cell renal cell carcinoma or CCRCC. Clear cell ang tawag dito dahil merong abnormal na pagkaipon ng cholesterol sa loob ng mga cells nito. Pag tinignan natin ito under histology, makikita natin na yung mga cells nito ay actually clear compared sa normal kidney cells. So, you may be wondering, paano ba tinitreat ang CCRCC? Since more than 90% ng mga cases ng CCRCC actually localized sa isang kidney, the easiest approach is through partial nephrectomy o yung surgical removal ng tumor galing sa kidney. However, sa mga cases na advanced na or higher in stages, sometimes hindi na ito localized sa kidney and that means it's spread all over the body, which ang tawag natin ay metastasis. Sa case ng metastasis, there's usually only one method of approach, yan yung chemotherapy. Pero as we all know, grabe talaga ang side effects ng chemotherapy. I mean, it's actually yung nahuhulog ang buhok, kita mo pumapayat ang mga pasyenteng ito. Of course, masakit rin sa katawan nila dahil yung mga chemotherapy ito talagang maraming side effects. Along with this, ang isang major problem sa CCRCC ay yung problem ng recurrence. That means bumabalik at bumabalik itong disease na to. Kahit 5-10 years down the road, bumabalik to sa other kidney or sa ibang part ng katawan. Dahil dito, importante ipagpatuloy natin ang research sa CCRCC in order to improve clinical outcome. So, this is where I come in. Ang lab namin ay nag-specialize sa mga nanoparticle systems. Gaya ng sinabi ko sa isang previous video, ang mga nanoparticle systems ay maliit na mga carriers na maaaring magamit upang mapabuti natin ang delivery and localization ng isang drug directly sa tumor. Dahil dito pwede nating bawasan ang off-target effects sa ibang part ng katawan, pwede nating tamaan yung bullseye ng tumor instead na mapunta pa sa ibang parts ng katawan at mapahamak ang mga normal cells. And because of these advantages, yung mga vaccine na ginamit sa COVID-19 gaya ng sa Pfizer and Moderna ay gumamit ng isang nanoparticle ang tawag ay lipid nanoparticles. Ginamit ang lipid nanoparticles sa pag-deliver ng mRNA sa COVID dahil kung in-inject lang natin ang mRNA diretso sa tao, kakainin lang yan ng mga immune cells natin at aalisin sa katawan instead na ma-develop yung ating immunity. So, ang nanoparticle system namin, ang tawag ay low density lipoprotein or LDL. Ang LDL usually considered yan as bad cholesterol. Yung blood work mo, makita mo dyan may level ng LDL, minimeasure yan ng mga doktor. As you may know already, yung mga LDL na yan ay actually na-stuck sa mga vessels natin which causes a blockade. Again, this turns into high blood pressure, heart disease, and so forth. However, sa lab namin, we actually re-engineer these LDL. Ang ginagawa namin ay inaalis namin yung cholesterol sa loob, nilagyan namin ng active drug which is our anti-cancer agent. Anti-cancer agent namin naman ay ang tawag docosahexaenoic acid or DHA. Ang DHA is a fatty acid na usually nahanap sa seafood or sa isda. Previous studies have indicated na ang DHA is actually healthy sa iyo. Pumunta ka actually sa isang pharmacy, makita mo na may tinitin na silang mga fish oil. Pag tinignan mo yung label, it's usually filled with omega-3 fatty acids gaya ng DHA. However, nung early studies in the early 2000s, nakita ng mga scientists na actually merong anti-cancer effect itong DHA na to. So now, nagtataka ka siguro, James, kung may anti-cancer effect to, bakit hindi na to ginagamit sa clinic? Bakit hindi na lang natin ito kinukonsume to prevent cancer? Well, number one, hindi ang DHA nakaka-prevent ng cancer, but it's only been shown to be useful in treatment of cancer. And two, bakit ba hindi na ito ginagamit sa cancer? Dahil ay once na pumasok yan sa ating katawan, sobrang raming barriers na kailangan i-overcome nito in order to localize it to tumors. So pag kinain mo lang yan sa tiyan mo, most of the time, nade-degrade lang yan ng katawan at hindi actually nakaka-localize sa isang tumor. Ang problema dyan is only 0.00001% ang actually nakakapasok sa kidney cancer mo, which is of course below sa concentration na necessary in order to actually see therapeutic effect. More importantly, since DHA is a fatty acid, parang itong pag na-mix mo ang tubig at yung oil, hindi sila mag-mix. And that's also because fatty acids are hydrophobic, meaning takot sila sa tubig. Hindi ito nakakapasok sa regions na gusto nating pasukin. This is where our nanoparticle system is useful dahil pwede namin i-package itong mga DHA na to sa LDL, and by re-engineering the LDL, pwede nating i-deliver yung DHA directly sa isang tumor. So ang goal ng lab namin ay using yung LDL nanoparticles na re-engineer namin in order to improve drug localization not only sa around ng tumor but also makapasok rin sa cancer cells. Ang tawag namin sa technology nito is LDL-DHA or low density lipoprotein docosahexaenoic acid nanoparticles. Again, I want to emphasize na yung LDL sa katawan natin usually pack yan ng cholesterol. That's why it's called bad cholesterol, right? However, yung LDL na ginagamit namin sa lab ay inalis na namin yung cholesterol at nilagyan namin ng beneficial fatty acid gaya ng docosahexaenoic acid. I think where our nanoparticle system actually shines compared sa ibang nanoparticle is yung system namin ay fully natural, right? So I mentioned yung LDL na sa katawan na natin. Actually, kinuha namin itong mga LDL na ito from a patient na merong hypercholesterolemia o yung abnormal na production ng LDL. So yung pasyenteng to kailangan pumasok sila sa clinic in order na maalis yung excess LDL nila. Those patients, kinukuha namin yung nakulak nilang LDL, ginagamit namin yun sa aming technology. Along with this, as I mentioned, yung DHA naman is naturally found sa isda or most seafoods. And again, pwede mo na ito mabili sa tindahan. Compare din again sa current chemotherapeutics na gumagamit ng mga synthetic chemicals na, of course, as we know, and I mentioned earlier, na talagang maraming side effects. However, marami pa rin kaming hindi alam sa system namin. So I cannot simply make the claim na mas magaling ang aming system compare sa mga gamot na nasa clinic na ngayon. Again, ito yung hypothesis ng thesis ko. So to test my nanoparticles, ang gamit namin actually itong mga cells na kinuha from cancer patients from back in the day. Mga cells na ito galing pa sa patients from the 1960s, the 1970s. And most of the time, hindi namin actually kilala even kung sino yung pasyenteng to. Basically, itong mga cells na ito ay pwede namin palakihin under isang plato, tawag namin ay culture dish or culture flask, na meron lang kaming special na liquid that allows them to grow and divide. Dahil lagi lang ito nagde-divide, maraming pwedeng experiments kaming gawin from these cells. We can ask questions such as, namamatay ba ang cancer cells after LDL-DHA treatment? Kung namamatay naman, paano namamatay? And again, of course, identifying yung mga different molecules at mga different parts dun kung paano namamatay ang cancer cells galing sa LDL-DHA and so on and so forth. Usually, these experiments are short periods, so pwede namin ulit-ulitin kahit hindi gumana yung first time. Ang isang pinaka-common namin ng experiment is basically nilalagyan namin itong mga cells na to sa isang flask and tinitit lang namin ang LDL-DHA over 1 day, 2 days, 3 days. And makikita namin kung may effect ba yung LDL-DHA namin na nanoparticles sa viability or how many cells are alive in each plate. So makita mo sa figure na to na ini-increase namin yung concentration ng LDL-DHA at meron kami ginagamit na reagent na nag-change ng color depending kung ilan pang cells ang buhay sa flask na yun. So kung buhay pa yung flask, yung color ng reagent namin ay orange. However, kung patay na yung mga cells, clear lang siya. By the way, ang tawag sa mga cell experiments na yun ay tawag namin in vitro experiments. So, ang problema sa mga in vitro experiments na to ay hindi kompleto yung story namin. Parang yung binasa mo yung likod ng libro o yung summary sa Wikipedia. Alam mo kung anong nangyayari or mangyayari at least, but you don't know the complete story. Similar sa research, syempre kailangan namin tingnan ang full picture or ang full story ng nangyayari sa CCRCC and our LDL-DHA nanoparticles. At hindi lang of course dun sa tumor cells na isolated system dun sa in vitro experiments namin. So, in order to overcome this, ang ginagawa ng lab namin ay nag-experiment kami sa mga animal models or sa aming case, mga daga. There's two types, right? There's rats and then there's mice. Yung rats mas malaki, yung mice parang maliit lang. So basically, ang ginagawa namin ay ginagamit namin yung cells galing sa mga in vitro experiments namin at tinatransplant namin yan sa target organ dun sa daga. So sa aking case, yung mga in vitro cells namin, basically kinukuha namin yung cancer cells na nilalagay namin sa kidneys ng isang daga and dun namin papalakihin yung tumor. Of course, once na lumaki na yung tumor, pinapalaki muna namin up to a certain size and then treat na namin with LDL-DHA to test naman kung how fast or kung meron naman effect ba sa size ng tumor. Not only can we look at tumor size and tumor weight, but pwede din namin tingnan ang overall picture, right? So case namin, pwede namin tingnan kung may side effects ba ang LDL-DHA sa aming daga. Pwede namin rin tingnan kung anong effects sa ibang organs. Pwede namin tingnan ang effects sa immune cells. I do want to note that yung mga daga namin actually is kept under sterile and clean environment. So, nasa control facility to and wala tong leptospirosis kahit kagatin ka. Also, mga animal experiments na to are highly monitored and legally, we are required na i-minimize yung pain ng animals dito. At the end of the day, living things to mga daga na to. So, we have to respect and acknowledge their contribution to the science. Meron kami mga vet and mga technicians na nag-aalaga sa aming mga daga. Kung anong kinakain nila, tubig, keeping the cages clean, and so forth. One of the experiments na ginawa na namin sa daga is binuksan namin yung katawan ng daga at nag-inject kami ng mga nanoparticles namin na may fluorescent labeled na nanoparticles, or basically nag-light up siya para makita namin kung saan talaga pumupunta yung nanoparticles. Pumupunta ba sa target kidney? Gusto namin makita na pwede siyang mag-localize sa isang part ng katawan instead na mag-spread lang kung saan-saan. Dahil yan yung problema ng current chemotherapeutics and yung side effects niya. So that's basically yung basis ng thesis ko. Gusto namin tingnan kung anong effect ng LDL-DHA na only sa in vitro cells, kung ano bang effect nila sa kidney cancer. Namamatay ba sila? Paano sila namamatay? But also gusto namin investigahan kung anong effect sa actual living animal. So in our animal models, gusto namin tingnan kung saan ba pumupunta yung LDL-DHA. Ano bang ginagawa niya sa katawan? Anong effect niya sa immune cells? And so on and so forth. However, so far, nandun pa lang ako sa part ng in vitro cells. So dun lang ako actually sa first part where I only work with the cells and hindi pa yung animal models. Actually, we only did one animal model so far as only a proof of concept. Mas mahirap kasi ang animal models, and again, from handling, time consuming pa rin. Kailangan mong palaki ng tumor, kailangan mong bisitahin every day and tingnan kung talagang lumalaki yung tumor. Kailangan mo ng approval from our animal facility, out of our protocol people. Kailangan approval ng vet. Animal experiments just require a lot of effort and also money. Ang pinakamura na ngayon na daga is actually between 3,000 to 4,000 pesos. So, ang mahal talaga. Hindi pa dito include yung price of facility. Kailangan may magpakain sa kanila. Kailangan may naglilinis ng cage. Hindi pa included dyan sa 3,000 to 4,000 pesos na price tag. So, kailangan talagang careful planning in order to do animal experiments, and since third year pa lang ako, wala pa ako sa part na yan. Now na binigyan ko na kayo ng overview ng aking thesis, ano naman ba ang day-to-day ko? So usually, gumigising ako ng 8 a.m., shower, of course, ng ngipin. Tapos usually magkakape muna ako. I drink almost 2-3 cups a day. As soon as natapos na ako dito sa bahay, nagkape na ako. Usually hindi naman talaga ako makain ng breakfast. Naglalakad lang ako kasi across the campus lang ang apartment ko. Now, nag-start ako once nakapasok ako sa aking building. Usually, pumunta ako sa computer ko at nagpa-plan ako ng aking araw. So, kung anong mga seminar kong kailangan na puntahan, anong mga experiments ko na kailangan kong gawin. Gusto ko lang talaga kasi may plano for the day. Kung hindi naman ako tinatamad, nagbabasa ako ng mga current articles sa aking field. So, sa akin, specifically yung mga kidney cancer field or nanoparticle field, bumabasa ko ng mga bagong papers na lumalabas. As I mentioned earlier, na kailangan ng cells ko ng special liquid. And usually, nakatago ang special liquid nito sa 4 degrees Celsius na fridge. However, kung kailangan i-add na to sa cells, kailangan nasa 37 degrees Celsius yung temperature. Kailangan mong ilagay yung mga bote sa isang water bath na mainit in order to give them to their proper temperature. So actually, most days, as soon as nakapasok ako sa aking building, pupunta ako diretso sa aming tissue culture room or TC room. Diyan namin ginagawa yung mga in vitro experiments namin. Ilalagay ko yung mga bote ng aking media or liquid sa isang water bath para mapainit ko na. Kung sa mainit yung media, I usually just stay there between 9 to 12 p.m. Talagang kasi usually maraming experiments. Kailangan mo mag-prepare ng mga bagong experiments. Kailangan mo i-process yung mga previous experiments mo. Usually talagang nasa tissue culture room lang ako. And again, yung TC room namin ay specialized siya na meron siyang mga hood. So itong mga hoods ito specifically is for biological experiments. So, pag ginawa namin ito sa hood, mami-minimize namin ang contamination. And also, of course, to protect ourselves from whatever disgusting stuff is in those cells. I do want to note that hindi naman to talaga nakakos ng cancer. Kahit ko pa kainin itong mga cells ito, which I will never do. Wala naman talaga itong effect sa aking katawan. Dahil yung kinuha to sa isang katawan ng isang pasyente, may mga methods na ginagawa sila in order to keep them alive out of the body. That usually removes their ability to be malignant and cause tumor in case na makapasok yan sa ibang katawan. Talagang 2 or 3 oras talaga lang ako nasa TC room, and it depends on the day. Some experiments naman, merong mga incubation time or talagang time na maghihintay ka lang. So usually, gaya nung dose response experiments ko, once na na-add ko ng LDL-DHA, maghihintay ako ng 2 or 3 araw bago ko ma-analyze yung data. So what I do during incubation time is usually nagbabasa ako ng mga current articles or nag-ubos ako ng oras sa TikTok. And to be honest lang, nakaka-boring sometimes to, especially when you're working with cells, dahil nagagawa ka ng experiments and then maghihintay ka. Nagagawa ka naman ng experiments and then maghihintay ka naman more. And ganyan talaga every day. It just becomes a routine, and of course, you just have to get used to it and keep your brain active by, either doing other experiments or magbabasa ka ng mga bagong article in order to just keep your brain engaged. And in order to overcome this, sometimes pag weekend also na walang tao ko lang, usually kinukuha ko yung Bluetooth speaker, and then I just blast music and sing along in the TC room. So around noon or 1 o'clock, nagla-lunch rin ako. Sometimes umuwi ako sa bahay dahil again, I live across the street and kung gusto ko makasave talaga, yung kakainin ko na lang yung leftovers ng dinner ko kagabi. Pero sometimes tinatamad ako maglakad pa uwi sa bahay and bumibili na lang ako ng pagkain sa campus. But recently talagang sobrang mahal na ng pagkain sa campus. Tinaasan actually nila ang price and it's hard to justify eating out every day. And then usually magkasama ko mag-lunch ay yung mga classmates ko naman or kasama ko lang actually sa lab. Kung payday, lumalabas kami and kumakain kami ng fried chicken or ramen, whatever we want to try that day. But recently actually, meron ako mga na-meet ng mga Filipino dito. I've been also hanging out with them and actually 2 weeks ago pumunta kami sa Jollibee and meron rin kaming Friendsgiving and kumain kami ng mga Filipino foods. And yung girlfriend ko na nagtatrabaho rin sa aking university, although she's in a different lab at hindi nagmamatch up ang schedule namin, tinatry ko rin mag-lunch kami sometimes together either dito sa bahay or dun sa campus. So sa hapon naman, inom naman ako ng coffee. And as I mentioned, pag umaga, nandun ako sa thesis room para i-prepare yung experiments. And ang wait time is around 4 hours or incubation time is 4 hours. So by the afternoon, by let's say 1 o'clock, 2 o'clock, kailangan ko nang i-analyze and collect yung data. Actually, to analyze this, sa labas to ng lab namin. So, i-prepare ko yung samples and dadalhin ko siya sa mga individual machines na nahahanap sa ibang parts ng campus namin. This afternoon session varies a lot. Ilang araw tapos na ako by 4 p.m. At usually, nasa computer ko na lang ako, nag-uubos ng oras by either reading papers or nag-organize ako ng data from the day. I-analyze ko sa aking computer and then ilalagay ko sa isang presentation in order to show my professor kung anong nahanap ko dun sa mga experiments na yun. Mayroong mga araw na natatapos pala ako sa thesis room around 6 p.m. And then, pupunta pala ako sa mga iba-ibang machines. So, again, usually natapos ako 8, 9, 10 o'clock. Depende lang talaga sa araw and depende kung how many samples I have. As I said sa previous video, wala kaming regular hours as grad student, at least dito sa university namin. So, hindi kami nagka-clock in, hindi kami nagka-clock out at the end of the day. And sa amin talaga, it's up to us kung paano namin i-balance yung aming oras. Pasok ako minsan ng 9 a.m. and then uuwi ako minsan ng 4 p.m. or papasok ako ng 9 a.m. and uuwi ako ng 10 p.m. Usually mga 13-hour days. So talagang depende lang yan sa araw, depende kung anong experiments mo. So yung boss ko naman talaga, fortunately, hindi naman siya micromanager. So wala siyang pakialam kung anong ginagawa mo during your day as long as you get the data that you need. So hindi naman kami ni-require na nasa lab for 8 hours, hindi naman kami ni-require na nasa lab kami 12 hours. But then again, that's bittersweet, right? Kasi sometimes hindi mo alam kung anong oras mo and you're there longer than you expected. Actually, half of the time, pumapasok ko rin ako na Saturday, Sunday, even though we're not required. Dahil yung mga experiments ko, they will fall in those days and I have to process them. After all this experimentation, all of this stuff, uwi na ako sa bahay, whether that's 4 p.m. or 8 p.m. And then usually nagluluto ako ng pagkain for dinner. Magre-relax lang ako and playing on my computer. Back then, I used to play Call of Duty sa computer ko at the end of the day. But now haven't found the energy to play video games again. So usually talagang nanonood lang ako ng TV, Netflix lang on my couch, actually my living room here. Overall naman talaga, if you haven't noticed yet, Monday naman talaga ang buhay na isang grad student or PhD student dito, especially if you're in STEM. Kasi some days na wala kang experiment dahil either hindi gumana yung previous experiments or naghihintay ka pa para you have enough cells for an experiment or incubation time. Responsibility mo talagang mag-keep up sa science today. Of course, keeping your brain active kasi it's easy to get complacent and then you get bored and you lose motivation to finish your degree. Again, yung boss ko, hindi siya micromanager. So, kami ang bahala kung ano talaga ang gagawin namin sa isang araw. Yung boss ko, call my boss, but yung professor ko is very chill and wala naman talaga siyang pakialam kung nandito ka for 6 hours, kung nandun ka sa lab for 10 hours. All he wants is that you have the data to present by Monday, which is yung lab meeting namin is usually Monday every week from 9 a.m. to 12 p.m. Kung naboboard kami ng mga kaklase ko, yung kasama ko sa lab, pag talang those slow days, lalabas kami for 1 or 2 hours and kakain lang kami mag-usap-usap and we joke around sometimes na we should just start a podcast dahil kung ano na lang pinag-uusapan namin. Ang importante talaga dito is discipline. It's easy to be complacent, to get complacent. And some days, talagang tinatamad ako. I mean, I know if I don't have any experiment, wala akong kailangan gawin sa lab. And I know that I still have to go to lab. Sometimes, bubuhat ako ng mga 10 or 11 a.m. ng umaga. And I go home at 3, and it's easy to fall in a pattern where you don't do much work, you're not productive. And again, that will just hurt you kasi mapoprolong lang ang degree mo. And this stuff is I would say it's really not for everyone, if we're being honest. Kasi pwede ka man kumuha ng actual job and you will get more money. Pero for us, especially gaya namin ng mga aspiring scientists, aspiring clinicians, gusto namin, I hope someday, research naman na to pwede ma-translate it, mag-benefit sa clinic, hindi lang exclusive sa cells and sa labs namin, but of course, be able to work and be used on people in order to benefit them. And with that being said, I hope my explanation for my science, it's sort of clear, and I gave you a glimpse of ano naman ba ang day-to-day ko experiences dito sa lab. Thank you so much for watching and for listening to me ramble. This is James, your PinoyPhD, and I'm out. Peace.